Okay, so today we're going to talk about real numbers. So basically, real numbers include all the numbers we have talked about: natural numbers, whole numbers, and then integers. And also we talk about fractions, decimal, and percentage. Those are all the same. It's just a different way or different form to present the numbers. So today we're going to talk about real numbers. That includes the numbers that we have talked about, but then we also will cover something more. Now, first of all, let's talk about the difference between rational numbers and irrational numbers. We call the person rational, right, when the person is making sensible decisions. Or you call some person irrational because that person is very inconsistent, making not sensible decisions. But then, interestingly, people use it to describe numbers, and we'll understand why in a few minutes. Now, first of all, it's a review, right? Natural numbers or counting numbers, whole numbers, integers. Now let's talk about rational numbers. Rational number is a number that can be written in the form P over Q. In other words, that can be written in the form of a fraction. Okay, that can be written in the form of a fraction, where P and Q are integers and Q cannot be 0. Now remember, if it's a fraction, the denominator can never be 0.
0.
Yeah, it can never be 0. Okay.
Yeah.
Now, for example, if you look at fractions here, all fractions, both positive and negative, are rational numbers. A few examples are 4 over 5, negative 7 over 8, 13 over 4, and a negative 20 over 3. Now, are integers rational numbers? In other words, how about numbers such as 3, negative 8, or even 0? The answer is yes. For example, 3 can be written as 3 over 1. Negative 8 can be written as negative 8 over 1. And 0 can be written as 0 over 1. Okay? So even though you don't usually write it like this, you don't usually write it as 3 over 1, negative 8 over 1, and 0 over 1, but as long as they can be presented this way, then we know even numbers such as 3, negative 8, and 0, which are integers, are also rational numbers. Now, I want to give you a little bit of a practice, okay? Write each as the ratio of two integers. Write each as the ratio of two integers. The first one, negative 15. How can you write it as the ratio of two integers? Negative 15. So it's negative 15 is negative 15 to 1, right? Which is negative 15 over 1. The other one, okay, you know what? Maybe I can. Yeah, see? Negative 15 over 1, right? Write the integer as a fraction with denominator 1. How about the second one? 6.81. How can you write it as the ratio of 2?
6.81 divided by 1.
Yeah, or in fact, the other way of saying it is 681 divided by 100. Okay,
Yes.
681.
Okay.
You know what? Why it can't be 6.81 divided by 1? Because the numerator has to be an integer. It cannot be a decimal. Okay?
Oh.
So because of that, you have got to change it to 681, but then divided by 100. Now the third one, okay? The third one is already a fraction, but it's a mixed number. So all you need to do is to change it to the improper fraction. Do you still remember how to do it?
It's 27.
Yeah.
Negative 27.
Yeah, 7 times 3 is 21, plus 6 is 27, right?
27 divided by 7.
Yeah, exactly. But don't forget about the negative sign. Okay.
Yes, sir.
So yeah, so that's basically what rational. What was the definition of a rational number? In other words, as long as you can turn it into a fraction, and in this form, okay, where q is not 0, and then both p and q must be integers. That's why it cannot be 6.81, right? It has to be 681 divided by 100. Then it is a rational number. So that's so good?
Yes.
Yeah, so these are some examples of rational numbers. These are the one on the right-hand side are the integers, and the one on the left-hand side are the fractions. Now, as you can see, fraction can be presented as decimal. It can be presented as, you know, a ratio. It doesn't really matter. They are all the same value. It's just the outlook is different. I often use the example. It's just like someone is dressed up in different way. Now, irrational numbers, are there any decimals that do not stop or repeat? Now, I'm not sure if you still remember when you went to elementary school, they introduced a very special number called pi.
Yeah.
Okay, you know, pi is a
Yeah.
very interesting number because basically no one knows exactly what pi is. Somehow this number keeps going. Okay, my daughter told me once one of her classmates was able to memorize, I don't know, a lot of the digits. Okay, yeah. So usually when we are doing the calculation, we use 3.14.
3.1.
Yeah, 3.14, right? Or sometimes, you know, if it is an estimation, you can even use 3, right? But what I'm trying to say is we are using the estimate, right? But to do the calculation. But no one will use the exact value of pi to do the work because somehow the decimal form keeps going. And that is what we mean by irrational number.
No.
If you take a look of this, you know, this definition here, an irrational number is a number that cannot be written as the ratio of two integers. Its decimal form does not stop and does not repeat. Now, not only that it does not stop, but it does not repeat. For example, the number 1/3. Does anyone know what is the decimal form of 1/3?
1.333.
Yeah, it's just 0, 0.3,
Yeah. 0.3.
you know,
333.
repeating, right?
Yeah.
Now, even though that number doesn't stop, but it's still considered a rational number because there's a repeating pattern. But if you look at pi, no, they just keep going and you don't even see any pattern, right? 141592654, blah, 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 you know, that's what we call irrational number. So 1/3 or 2/3, right? Even though repeating, but then they are rational.
Okay.
So I guess if you think about the meaning of rational and irrational to describe a number, rational basically means you can pretty much predict the form of the number. For example, even though 0.3, right, keep going without an n, you know it keeps it's the number 3 that is keep repeating. But irrational number is unpredictable, right? You cannot even come up with any pattern. So that is what irrational number is about. Now, why don't we take a look at example 7.2. which number is rational and which is not rational. A, is it rational?
Yes, is rational.
Yes,
Because 3 is continue.
Exactly, because even though it keeps going, but the number 3 is the one that keeps repeating itself. So at least you can predict, right? You
Yeah.
can predict the pattern. B, is it rational or irrational?
Yes, it's rational
Yeah.
because it's not repeating.
Exactly, and it stops, right?
Yeah.
And then how about C?
Irrational.
Irrational.
Thank you, Nami. Yes. So thank you, Priyansu. So yeah, you are so right. The first one is a repeating decimal, therefore a rational number. The second one stops after the 5, so again it's a rational number. The third one means the number does not stop. Okay, when you see the dot dot dot, it means the number does not stop. Now, the number does not stop is only one condition. Then you want to see if there's any repeating pattern. Well, not exactly. Not exactly. You cannot see any repeating pattern. Because of these two conditions, then you say, oh, this number is irrational. Now, how about this one? Let's think about square roots. Square roots of a perfect squares are always whole numbers. For example, the square root of 4 is 2. The square root of 9 is 3. So they are rational. But the decimal forms of square root of numbers that are not perfect squares never stop and never repeat. So these square roots are irrational. Now, for example, the square root of 36, rational or irrational?
It's rational.
Is rational?
Yes, sir.
Yes, exactly. So because 6 times 6 is 36, the square root of 36 is 6. Now, secondly, square root of 44, is it rational or irrational?
It's irrational.
Irrational, very good. Yeah, because it's not a perfect square, and yeah, the square root is a number that is it's a decimal with no pattern and also doesn't stop. Okay,
It's
how
very good.
about, yeah, very good. So now this is a time for us to step back rather than looking at individual trees to look at the forest. So far, this is what we have learned, okay? We have learned natural numbers or counting numbers, 1, 2, 3, 4, 5. And on top of the counting numbers, we have a concept called whole numbers, which is basically counting numbers and 0. And then on top of whole numbers, we have integers. Integers are all the whole numbers and then the negative integers. Okay.
Integers.
And then we have rational numbers. Rational numbers are numbers that are integers or can be presented in the form of a fraction with p over q, and q cannot be 0.
Okay.
And p and q must be integers. And then we talk about, so this is basically what rational numbers are. And irrational numbers are a decimal with no n and no pattern. Okay, so all of these are under the umbrella of real numbers. Yeah, so take a look of here. Determine whether each of the numbers in the following is a whole number, integer, rational, irrational, and real number. Now, please understand that a number that is a whole number is also an integer. Okay, so in other words, when you try to answer this question, for each number, they have more than one label. Okay, now for example, let's take a look of -7. -7, is it a whole number? No. Is it an integer? Yes. Is it a rational number?
Yes.
Yes. Is it irrational? No.
No.
Is it a real number? Yes.
Yes.
Okay. So I want you to do the other ones. Okay. 14 over 5, 8, square root of 5, 5.9, negative, and then square root of 64. And then you tell me what their label should be. I'm going to give you 1 more minute.
Okay.
Okay, let's take a look at the second number. Is it a whole number?
No.
Is it an integer?
Yes.
No, the answer is no. Integer is basically all the whole numbers as well as negative integers. For example, -2, -3, -4, 0, 1, 2, 3, 4, 5. Okay, those are integers. Is it a rational number?
Yes.
Yes, I think so, because it can be presented as
2.8.
14 over 5. Yeah.
2.8.
So is it irrational?
No.
Is it a real number?
Mm.
Is it a real
Yes.
number? Yes. Okay.
Yes.
How about the next one? 8. Is it a whole number?
Yes.
Yes. Is it an integer?
Yes.
No.
Is it a rational
Yes.
number?
Yes.
Yes. Is it a real number?
Yes.
Yeah, good. How about square root of 5? Is it a whole number?
No.
No.
Integer?
No.
No. Rational?
No.
Irrational?
Yes.
Yes.
Yes. A real number?
Yes.
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 Very good. How about this one? 5.9. Is it a whole number?
No.
Is it is it an integer?
No.
No. A rational number?
Yes.
Yes. Irrational?
No.
No.
Real number?
Yes.
Yes.
Yes. By the way, square root of 64 is 8. So the answer of this number is -8. Yeah. So very good. Very good. Okay. Now, so they actually have drawn a table. Okay. So -7 is integer, rational, real. Okay. That's actually how you can do it, right? I mean, if you are asked such kind of questions. Yeah, so that's basically it for this section. Do you need a break?
No.
Okay. Now let's talk about the second section, which is what we call the commutative and associative properties. Okay, commutative and associative properties. Now, first of all, think about these two numbers, 5 and 3. Uh, 5 plus 3 equals to 8. But then 3 plus 5 also equals to 8. In other words, the order in which we add does not matter. Now, it's not always like this. For example, if I have 5 minus 3, now then the order makes a difference. Because 5 minus 3 is 2, and then 3 minus 5 is
-2.
minus 2, right? So the commutative property applies to addition and multiplication. Okay, we call that the commutative properties of addition and the commutative property of multiplication. Now let's take a look at this example. Use the commutative properties to rewrite the following expressions. For example, the first one, -1 plus 3. You
2.
can write it as
2.
No. It's asking you. It's not asking you to calculate this expression. It's asking you what is another way you can write it. So since since this is an addition, so it doesn't matter which order it is.
Mhm.
So -1 plus 3 can also be written as 3 plus
Negative
-1,
1.
right? So
Mm.
this is what we mean, okay?
Okay.
Now, how about the second one? 4 times 9.
9 times 4.
9 times 4, very good, okay? Now, how do you tell the difference between whether it's a multiplication or it's a decimal?
Multiplication dot is in the middle of the middle, and the
Yeah.
decimal dot is below.
Yeah, exactly. And also the space between the two numbers tend to be more, right? If
more,
it's a multiplication. Yes, very good. Now, so let's talk about a subtraction, right? Subtraction and division. Now, the commutative property does not work because 7 minus 3 is not the same as 3 minus 7. 12 divided by 4 is not the same as 4 divided by 12. So let me see. Now let's take a look at this. Now this is another property. It's called associative property. Now let's take a look. Okay, when you try to add something or multiply something, right? Usually the parentheses, the bracket, are grouping the symbols that indicates which operation should be done first. However, when you add the numbers, changing the grouping of the numbers does not change the result. Also, when you multiply the numbers, changing the grouping of the numbers does not change the result. For example, a plus b with the parenthesis plus c, which means you are supposed to do a plus b first, right? But the reality is it's exactly the same as a plus b plus c with the parenthesis, because for the associative property of addition, the order does not matter at all. And it's also the same as the multiplication. Now let's take a look of this example. Use associative properties to rewrite the following. So you have a parenthesis, 3 plus 0.6, right? And then plus 0.4. In fact, you can put the parenthesis to the second and the third number.
Yeah.
Right? And then which is exactly the same, okay, because of the associative property. And also this one here, -4 times 2/5, right? Bracket times 15 is exactly the same if you use the parenthesis for the second and the third number. This is what we mean by the associative property. Now use this associative property of multiplication to simplify 6 and then bracket 3x. So first of all, we need to know which numbers are the like terms. 6 and 3 are the like terms. That means you can multiply them, right? So 6 times 3 is
18.
18. And then you have the x. Can you further simplify it?
18x.
Yeah. Can you? So do you think 18x is the simplest way? Can you do anything more than that? 18x. Is that it? Can you go any further to further simplify it?
No.
Yeah, you're right. No, because you can only multiply the like terms, right? Which 6 and 3. So 6 times 3 is 18, and then x. Okay.
Yeah.
Note that we can multiply 6 by 3, but we cannot multiply 3 by 6. That's why we need to do 6 times 3 first instead. Okay. And it does not change the value of it. Now evaluate expressions using commutative and associative properties. Now let's take a look of this. Okay, the commutative and associative properties can make it easier to evaluate some algebraic expressions. Since order does not matter when adding or multiplying 3 or more terms, we can arrange and regroup terms to make our work easier, as the next several examples illustrate. Okay, now let's take a look of this.
Yeah.
Now, how can you evaluate the expression if x equals to 7/8? Now, you may think that this is very complicated, right? Because you have fraction and decimal. But if you read closely, 7/8 plus 0.37 and then here plus minus x, that means minus 7/8, right?
7/8.
So 7/8 minus 7/8 is 0. Because of that, the answer is
0.37.
Exactly. Now the second one again is also very easy, right?
It's the same.
Yeah, the x cancel each other out, so the answer is also 0.37, right? You don't even need to do anything. So yeah. So or theoretically, you need to put the number in substitute x with number, but in reality, you don't really need to do that because somehow they cancel each other out. So how about this one? Now this time I think you need to do something. Okay, evaluation expression when n equals to 7. What is that?
3.
Sorry, I mean n is 17, not 7. 17. Now interestingly, 4/3 times 3/4. If you look closely, 4 times 3 is 12. 3 times 4 is also 12. So 12 divided by 12 is 1, right? So 1 times n, meaning 1 times 17.
17.
So the answer is 17. So same here. 4/3 times 3/4. Okay, if you multiply these two numbers, and then you see that the answer is 1 here. 1 times 17 is 17. So the answer is 17. Okay. Now you can simplify expressions using the commutative and associative properties. For example, this one is an expression with the variable n. Now, first of all, n is, you try to find the like terms, right? So n is the like term. And then negative 84 plus negative 73. So which is?
Answer is minus 73.
Actually, because of the minus negative 84 and the plus 84 is.
Yeah, but then you add plus 84 n. So in other words, it's negative 73 n, right? Yeah, negative 73 n. And simplify. Yeah. How about this one? Now we will see how recognizing reciprocal is helpful, right? Because if you go back to here, you see that when you multiply by the reciprocal of a number, that actually is always 1. Okay? For example, 4/3 times 3/4. 3/4 is the reciprocal of 4/3. So it's always 1 if you multiply them. Okay? So that's why it says here. You will see how recognizing reciprocal is useful. Before multiplying left to right, look for reciprocals and their product is then 1.
1.
Yeah, exactly.
It is open 23.
Yeah, so I think this is actually quite straightforward, and yeah, you know what, I think sometimes Yeah, how about here?
Yeah.
This time you need to simplify these fractions. Now again, before you try to simplify it, you take a closer look, okay? You can actually do this part, to do the second and the third number first. What is 3 over 4 plus 1 over 4? What is 3 over 4 plus 1 over 4?
4 upon 8.
How about this? You have
4
three
over
3/4 of a pizza plus 1/4 of a pizza.
4 over 4.
Yeah, so it's 1, right? It's 1. 4 over 4, that is 1, right? 4 over 4 is 1. So the answer is 1 and then 5 over 13. So it's a mixed number, right? But you don't even need to change the denominator into the common one, because you can simply do the second and the third number first, and then you just add 1 to it. So the answer is a mixed number, which is 1 and then 5 over 13. Now, if you need to change it to an improper fraction, right, then it goes like 13 times 1 is 13, plus 5
Plus
is
5.
18. So it's 18 over 13. But I'm not even sure if you really need to turn it into a improper fraction. Okay, it doesn't say. So I guess, yeah, it's okay if you leave it as a mixed number. So how about this one? When adding or subtracting 3 or more terms involving decimals, look for terms that combine to give the whole numbers. For example, yeah, this one looks complicated. But if you do this, do the second and the third number first, it would be much easier. What is 9.99 plus 1.01?
11.
11, exactly. So 11 plus 6.47. 11 plus 6 is
17.47.
yeah, 17.
17.47.
Exactly, 17.47. Now you may think that, hey, you know what? Why do we need to learn all these tricks? Because nowadays, if you use the calculator, right, it doesn't make a lot of differences. However, let me remind you, sometimes, you know, what if you don't have a calculator with you, or if you don't have the smartphone with you, right? So in this case, does it mean that we can't do any calculation without the machine? So those are some of the very basic techniques that I think we should learn, right? And although in reality, I have to admit, compared to 20, 30 years ago, or sometimes this skill, people may not find it as useful as before, because people carry the smartphone with the calculator, yeah, all the time, right? But that's you know what? Let me share with you something. I want to sidetrack a little bit. I remember when I was a child, I used to watch a TV show, and then in the show they had um, a very short episode. It was about a teacher asking an elementary school student a very, very difficult math question, right? But then the student can easily do it with the help of the calculator, okay? But then the teacher then asks, okay, very good, very good. Okay, then how about 1 plus 1? And that student could not answer him, okay? Now, obviously, it's a joke. However,
Yeah.
I have a feeling that as we rely so much on our calculator, somehow our ability to do calculation is getting weaker. I'm not only talking about you, okay? It also happens to me, okay? So I don't know, but I think even though we have the calculator, you know, these are some of the things we still want to know, okay? how to do it, right? Or how to do it in an effective way. Okay, I think there's a difference between you just plug the numbers in, getting number without knowing how the number is how the answer is generated,
Mm.
and there's a difference that you know how to do it. You simply use the
Yeah.
calculator to help you, right? I think there's a major difference between the two. So now let's take a look of this one. Simplify this expression. Now again, if you do the first two numbers, they look very difficult, right? But if you do the second and the third one first, it will be much easier. Do you know what is 8 times 0.25?
2.
2. Very good. So now once you figure out this is 2, then you go 2 times 1.67. It's much easier, right? So what's the answer of that? 1.67 times 2 is
3.34.
3.34. Very good, very good. And then now simplify this one, right? Yeah, 6 times 9 is 54. So it's 54x.
X.
Very good. And how about this one? Now see if there's anything you can do this one is actually, you know what, you've got to be very careful because now we have two variables,
Yeah.
P and Q. You can only do the addition and the subtraction of the like terms, right? So 18P, and what is the other like term?
Minus 15p.
Minus 15P. So what is 18P minus 15P?
3p.
3P. How about 6Q? What is the like term?
6q plus 5q.
Which is
11q.
11Q. So the answer is 3P plus 11Q. Now, how do you determine whether you write P first or Q first?
It's no matter. You can.
You know what? Yes and no. It doesn't change the value, right? 11Q plus 3P is exactly the same as 3P and plus 11Q. However, just like when you go to a ballroom, if you want to dress yourself up appropriately, you go by the alphabetical order. In other words, P comes earlier than Q. That's why you write P first.
Okay.
Just like when you have three variables, A, B, C, right? You usually write A first, and then B second, and then C third. Even though it doesn't matter, even if you change the order, right? You can write C first, and then B second, A third. It's almost like you go to a ballroom dance, and then you wear jeans. Yeah. You know, that's interesting. As a teacher, do you think I should deduct marks when people do not dress themselves up properly, when they present something that is correct, but it's just that the form is not very appropriate? What is your suggestion? Should I take marks off?
Yeah, actually, I can get marks off in assignment number 2 in the writing of factors, because the writing is 2.2. I just write 2, 3, and 5. The factors are 2 into 2 into 2, 3 into 3 into 3, and 5 into 5. But I just write 2, 3, and 5.
Yeah.
That's why I cut the 2 marks.
Okay. Yeah, you know what? Even though I deduct a little bit of the marks, right? First of all, it shouldn't affect your overall grade significantly. You should not, right?
Yeah.
And secondly, I guess it's just to remind you a little bit, right? Yeah. So this is probably the better way to present your answer. Yeah. So so this is very good. Okay. Now, does anyone need any break?
I don't know.
Are you sure? How about the rest of you? Navni and Paul, do you need any break?
No, it's okay.
It's okay. Oh, sure.
No, sir. Continue.
Okay, that's okay. So if you don't want any break, that means we can Now let's take a look at what we call distributive property. Now this is what we mean by distributive property. Now, if you have okay, an expression, A multiplied by parenthesis, B plus C, right? Is actually the same as A multiplied by B plus A multiplied by C. And this is what we call distributive property. Distributive property, okay? Now, for example, here, you have 3 and then parenthesis x plus 4. Now, how can you present it using the distributive property? So first of all, it means 3x
x plus 4 3 into 4.
3 times 4.
Yeah.
Which is 12.
12. Yeah.
Okay. So this is how you do it, right? 3 times x plus 3 times 4, and then 3x plus 12. Very good. So now let's take a look at this one.
6 into 5y plus 6 into 1. 30y plus 6.
Okay, any other comment? Is it 30y plus 6? How about Navmi? How about Emery Paul?
I think it's
you think so? Okay.
yeah.
Yes. Okay. 30y plus 6. Very good. Now, how about this time? If I turn it into variables, right? So and then a times b plus a times c. But you know, interestingly, even though you have b minus c, it still works. So it's the same as a times b minus a times c. Okay, or even if your parenthesis is at the beginning, right? So it can also be presented as b times a plus c times a. Now, how about this one? This time it's a mixture of variable and number, right? So 2x minus 2 times 3 is
6.
6. So it's 2x minus 6.
Minus 6.
Now, how about this one?
This one. 3.4 and plus 9. Sorry, 3 plus 3.
No, in fact, I think your first answer is right. Now, 3 over 4 times n, right?
Yeah.
And then 3 over 4 times 12. Now,
yeah, the 4.
Yeah, so 3 times 12 is 36. 36 divided by 4 is 9.
Yeah.
Okay, so
3
this is
over n
your
plus
answer.
9.
Yeah, plus 9.
Yeah.
3 over 4n plus
Plus
9.
9.
Now, how about this one? Now, this time, let me have Navmeet try to see if you get the answer for this. Navmeet?
Okay, sir.
Yeah.
What? My answer is ready, sir.
I know you. Yeah. I just want to see if
Yeah.
another student can. Yeah, go ahead, Navmeet.
It has to be 8 into 3 over 8x plus 8 into 1 over 4.
Yeah.
So it means 3x.
Very good.
Plus 2.
3x plus 2. Very good.
Yeah.
Okay. So yes, and yeah, so distributive property. Okay. So and then 8 times 3 divided by 8 is 3x. And then 8 divided by 4 is 2. So it's 3x plus 2. Oh, so good. So good. How about this one? Henry Paul, see if you can figure this one out.
100 plus 0.
Yeah, so now, you know what, this one is interesting because we're dealing with 100, right? So when you multiply a decimal number by 100, all you need to do is to move the decimal 2 places to the right. So 0.3 times 100 is what? 30.
30.
30, right? So 30, and then how about 100 times 0.25?
25.
25. What is the final answer?
55.
Yes. No. It's not 55, right?
Oh, sorry, 30 plus 25
Yes,
cube.
it's 30. Yeah.
Yeah.
This one has no variable, so it's 30
Yeah.
plus 25 cubed.
Yes.
Yeah, I'm pretty sure you should be able to handle this. It's just that sometimes you need to be careful, right, regarding your calculation. How about this one? M times n minus
4m.
4m. Very good. M times n minus 4m. And this one?
Px plus P8.
Yeah, yeah, px plus. Oh, in this case, you probably want to say xp, right? Because
Yeah.
your second one is 8p, so xp plus
P plus
8p.
8p.
Yeah. Oh, they actually use px.
Yeah.
Okay. Whatever. Yeah. Yeah. It doesn't change the value anyway. So I think we have a difference in terms of the fashion. They prefer this to be dressed up like this. I prefer to be dressed up a little bit differently. But anyway. So how about this one?
It's minus 8y plus
12y plus 2.
minus 1, minus 2.
Yeah, minus, so negative 8y minus 2. Negative 8y minus 2. How about this one?
It's minus 44 plus 12a.
33a.
Sorry, 33a.
Very good. Very good. Yeah. And usually people, if they have something like this, they tend to move 33a to the front because usually people like to show the terms with the variable first.
Okay.
Okay. Again, it's like going to a party, right? How you dress yourself up. Yeah. They are the same. It's just that the outlook is different, but it's the same value. Now this one is easy, right? If you have negative sign in front, all you need to do is to change the sign to the opposite one. So the first y, which is supposed to be positive y, has now been changed to negative y. And the second number, positive 5, is now changed to negative
5.
And how about this one?
6x plus 12.
6x
plus 12.
6x plus.
Yes. Yeah, because minus 2 times 3 is negative.
Yeah.
So yeah, so it's plus 2.
6x plus 18, right?
Yeah.
No, this negative 2 times 6, right? The 8, the 8 does not affect the x. So okay. So first of all, okay, you don't worry about the 8 first. Okay, you only take a look of this part. Okay, you don't worry about the 8. So it's negative 2 times. Sorry, it's 2 times x is 2x, right? And then 2 times 3 is 6. Okay, 2 times 3 is 6. So then because it's a minus, so 8 minus 6 is 2. But then you don't do anything to the x because 8 here is not a like term of x.
Yeah.
So because of that, it remains to be negative 2x plus 2. Okay, let's see if you can do this one. Be careful, okay? It's easy to make mistakes.
3x minus 35.
Very good. Very good. How about the rest of you?
Yes, please.
Got it? Okay. Now, evaluate expressions using distributive property. Whenever it says evaluate expressions, that means they give you the value of the variable, and then they expect you to put that number into the expression. Okay, so y equals to 10. So you can use distributive property if you want, but or the other way is you can just do it inside the parentheses. So 5 times 10 is 50.
Yeah.
50 plus 1 is 51. 51 times 6 is
306.
3. I think it's 306, right? Yeah, 306.
Actually, sir, we can do this. Put a 50. 6 into 15 plus 6 is the easy way.
Yeah. Exactly, right? If you use the distributive property.
Yeah.
So yes, yeah, you're right.
6 into
5
50.
times 10 is 50. 6 times 50 is
It's
300.
300 plus 6.
Plus 1, so which is 306. Exactly. This is why in this case, if you don't have a calculator, using distributive property to do it may be easier.
Yeah.
And how about here? Again, it's the same thing. They use the distributive property, right? So this time, if y is 3, negative 2 times 4 times, okay, 4 times 3 is 12. 12 times negative 2 is negative 24, right? And then plus negative 2 times 1, which is negative 2. So 24 minus
negative
2. Sorry, I mean, sorry, what am I'm talking about?
Yeah.
Sorry. Yeah, 4 times 6 is 12. 12. Yes, it's negative 24, right? And then minus 2, right? Which is negative 26.
Actually, sir, this is the first A answer, not the B1 answer. Yeah, this is the answer.
Yeah, so this time, yeah, I think the whole idea is like you can, play around with the order,
Yeah.
right, and see which is the easier way to do it. I'll leave it. You may try to do. You know what? Oh, that's okay. I think it's very much the same as the previous one, right? Yeah. So this time you can, again, make use of the distributive property, right? And yeah, so. Okay, so this is what distributive property is about. Now let's talk about the, you know what? Yeah, I mean, our class should not be very long, so we just need to talk about a few more things, and then I'll let you go. Now, identity properties. Identity property of addition for any real number. If you add 0 to the number, it won't change the value of the number, right? I mean, it's so, it's so understandable, right? Because when you add 0 to the number, obviously you don't change the value of it. On the other hand, the identity property of multiplication is that if you multiply a number by 1, you don't change the value of it. Okay, now you may find that, hey, you know, why do we need to learn these two properties, right? It's so, it's so simple. The reason why you sometimes need to do it is to use these properties as a tool, okay, to solve the equation. Now let's take a look here. Use the inverse properties of addition and multiplication. What number added to 5 gives the additive identity 0? 5 plus negative 5 is 0, right? So this is the inverse properties of addition and multiplication. What number added to negative 6 gives the additive identity of 0? So if you put 6 here, negative 6 plus 6 is 0. So we called negative A the additive inverse of A. Okay. So on the other hand, the multiplication inverse is the number that when you multiply a fraction, the answer is 1. So in other words, is basically the reciprocal of the number. For example, the multiplicative inverse, right, of 2 over 3 is 3 over 2. So it's the reciprocal of number is multiplicative inverse. Okay, how about this? Find the inverse additive inverse of each expression. In other words, for the first one, the additive inverse of 13 is negative 13. The additive inverse of negative 5 over 8 is positive 5 over 8. And the additive inverse of 0.6 is negative 0.6. How about the multiplicative inverse? What is the multiplicative inverse of 9?
1.
No, it's actually the reciprocal.
Okay.
The number that multiply 9, which can make the answer to be 1. So in other words, it's 1 over 9. Okay.
Yeah.
How about B?
No.
It's negative 9.
Negative.
Yeah, which is the reciprocal of negative 1 over 9. How about C? Now, C is a little bit tricky, right? Because it's not a fraction. So before you do it, you first change it to a fraction. So 0.9 is the same as 9 over 10. And the reciprocal of 9 over 10 is 10 over 9. Okay? So the multiplicative inverse of 0.9 is actually 10 over 9. The reciprocal of 9 over 10. Now, multiplication by 0, no matter what you do, no matter what number you're talking about, when a number is multiplied by 0, the answer is always 0. Okay? So it's easy. Okay? The answer of all these are 0. Okay?
Yeah.
And I don't want to talk too much about that. Now remember, you can if 0 is divided by a number, it's also always 0. But then you cannot have a number divided by 0, right? That is not possible. Division by 0 are undefined. Okay, so yeah, these 3 answers. What are the answers? They should all be the same.
Is the we cannot divide it by the 0 actually.
Exactly. So undefined.
Yeah.
Undefined. Okay. Undefined. Now properties of 0. Okay. A times 0 equals 0. 0 times A equals 0. Division by 0 for any real number A. If it is a denominator, cannot be 0. Okay. Anything divided by 0 is not defined. Yeah, I think this one is easy, right? 3x minus 3x is 0. 0 plus 15 is 15. Yeah, I'm not going to spend too much time on this because they are so straightforward. And this one, now 4 times 0.25 is 1, right?
Yeah.
So in fact, I think they want to show you that 0.25 can be written as 1 over 4. 1 over 4 is the reciprocal of 4. So 4 times 0.25 should be 1, right? So that is 1 cube. But even if you do it with the decimal, it's still very easy. And now how about the 0 divided by n plus 5, and n is not negative 5, right? Yeah, which has to be the case, because if n equals to negative 5, then it becomes divided by 0, then it's undefined, right?
Yeah.
So in this case, it's not undefined, but it's 0 divided by a number. So whatever number it is, 0 divided by whatever is always 0.
0.
Right? Unless it's divided, if 0 is divided by 0, then you can say it's undefined, right? But here we already say that, you know what, because n cannot be negative 5, so that's no way n will be divided by 0 here. Now let's take a look at this one. You multiply this okay. Now because it is okay that you do the first two terms first, right? So 3 over 4 times 4 over 3 is what? A number multiplied by the reciprocal is always 1, right? 1. So 1 times bracket 6x plus 12 is 6x plus 12. So the answer is 6x plus 12. Make sense?
Yeah.
Now this is a table that summarizes all the properties, and here's the exercise. Now the last thing I want to talk to you about is changing from one unit to another. I'm not sure if anyone has traveled to the United States. You know that their unit is not the same as ours, right? For example, we use kilometers. They use what? Miles.
Miles, yeah.
Yeah, we use kg, and then they
use pound.
Yeah, and then when we go to the gas station, right?
Yeah.
What do we use for our gas?
Actually, I don't visit the gas station, so I don't know.
Okay. Yeah, we use how many you know, how much for each kilometers, right? But they use miles, and then also they use gallon, right? They use gallon for the volume. We use liter, right?
Yeah.
So this is the difference. And here's a table that talks about, you know, how the system units are used in the United States. Okay. Now for this particular section, it's just to teach you how you convert it from one unit to another. For example, Mary Ann is 66 inches tall. What is her height in feet? Now, in order for you to answer this question, first of all, you need to know the relationship between feet and inches. 1 foot is 12 inches. So Mary Ann is 66 inches tall. In other words, you divide 66 by 12, okay? So what is that? So it depends,
5.5.
right? Yeah, 5.5. Or if you use the fraction.
Fraction?
Yeah. Okay, it would be 5.5, right? So which is the same. So this is basically what this section is about. So in order to answer this, it's actually easy, but you just need to know the relationship. So this is a table.
Yeah.
That shows you how the different units are related. For example, here you have an elephant. An elephant weighs 3.2 tons. Convert her weight to pounds. Now, first of all, how many tons? Okay, 1 ton equals to 2,000 pounds. 2,000, 1 to 2,000. Okay, so now you have 3.2 tons. That means you multiply
6,400.
Yeah, 3.2 multiplied by 2,000.
2,000.
Right? So what is your answer?
6,400.
Okay, how about Nafmi? Do you get the same answer?
Yes.
Yeah, how about Henry Paul?
Sorry, sir, I didn't get the answer.
Oh, you haven't got the answer? Okay, now because 1 ton is equivalent to 2,000 pounds. So now you have 3.2 tons, right? So all you need to do is to multiply 3.2 by 2,000. And the answer should be 6,400 pounds.
100.
Okay, yeah.
Yes, sir.
And now this one, okay. Juliet is going to their summer home with her family. She'll be away for 9 weeks. Convert the time to minutes. Okay. Now, this is actually not difficult. It's just a little bit annoying. Okay. So 1 week, we have 7 days.
Yeah.
Right. So if you have 9 weeks, so 9 times 7 would be 63 days. Right.
Yeah.
So how many hours do we have for 1 day?
24.
24. Okay, so then you have 60
Multiply by 24.
yeah, exactly, multiplied by 24. And then 63 multiplied by 24. So for 1 hour, then you have 60 minutes, right?
Yeah.
So then you have 63 multiplied by 24 multiplied by 60.
60.
Okay.
90,720.
Yeah. Okay. So 9 times 7 times 24 times 60. The answer is 90,720 minutes. Okay, now this one, Charlie bought 3 sticks for barbecue. Their weights are 14 ounces, 1 pound, 2 ounces, 1 pound, 6 ounces. How many total pounds of stick did he buy? So this is how you can do it, right? 14 ounce plus 1 pound 2 ounces plus 1 pound 6 ounces. So 14 plus 2 is 16. 16 plus 6 is 22 ounces. Okay, and then you have 2 pounds. However, okay, you don't want to leave it as 22 pounds. I mean 22 ounces.
Yeah.
Because you want to convert the 22 ounces to pounds, right?
Yeah.
So 22. How many ounces do we have per pound?
22.
No, I know.
Sorry.
I know the. Let's go
16.
back to here, right? If you're not
16.
Yeah. Okay. Yes. Okay. Pound. Okay. 1 pound equals 16 ounces, right? So in this case, you have 22 ounce. So 22 minus 16.
6.
Is
yeah.
6.
3 pounds 6 ounces.
6, right? So that means you have 1 more pound here. So it's 3 pounds and 6 ounces. Okay. And then Anthony bought 4 planks of wood that were each 6 feet 4 inches long. If the 4 planks are placed end to end, what is the total length of the wood? So basically, you just add them up. But let's not forget, right? How many inches do we have for 1 foot? So I think it's 12, right?
Yeah.
Yes. So 4 plus 4 plus 4 plus 4 is 12. So that itself has already become 1 foot.
1 foot it is.
And then you also have 6 plus 6 plus 6 plus 6, 24. 24 plus 1 is 25 feet. Yeah, 25 feet.
4 inches.
25
feet, 4 inches.
Oh, right, sorry. Yeah, here, 4 plus 4 plus 4 plus 4 is 16.
Yeah.
16, yeah, that's right. Yeah, so 16, yeah. So, yeah, then you have 24 feet and 16 inches. And then the 16 inches, out of the 16 inches, 12 of them is 1 foot. So it becomes 25 feet and 4 inches. So yeah, if you're talking about metric system, it's much easier, right? Because it's all metric system has to do with 10, 100,000 and so on. It's much easier. For example, how many meters did Nick run? Nick run? Okay, 10 kilometers. So it's 10,000.
1,000.
No, actually it's 10,000, right? Because 10 kilometers, right?
No, so, sir, actually I am converted to 1 kilometer to meter.
Oh, okay. Yeah. So it should be 10,000 right? Meters. 10,000 meters. Yeah, and this one. Eleanor's newborn baby weighted 3,200 grams. How many kilograms did the baby weigh? So this time, if you change it from the gram to the kilometers, you need to divide. You need to divide it by 1,000.
Yeah.
So 3,200 divided by 1,000 is 3.2, right? Yeah. 3.2. So it's 3.2. Yeah. Now this time, the baby is 2,800. How many kilograms did the baby weigh? Oh, sorry. No.
2.8.
Yeah, 2.8. Very good. 2.8. Very good. Examples: convert 50 liters to kiloliters. Now, if you change it from a smaller unit to a larger unit, right, that means you need to divide it,
Yeah.
right? So 350 divided by, now, when you see the word kilo, K-I-L-O, it means 1,000.
Yeah.
So it's 350 divided by 1,000, which is
4.35.
yeah, 0.35, right?
Yeah.
And the next one, now this one is from a large unit to a small unit. So you multiply it, right? You multiply it. So the first one you divide it by 1,000, so it's 0.35 kiloliter. The second one you multiply by 1,000, right? Milliliters. So it's 4,100.
4,001.
Now this time you have a mix. Ryland is 1.6 meters long. His younger brother is 85 centimeters tall. How much taller is Ryland than his younger brother? So you add them up, but then because you have 85 centimeter, so
yeah, in addition,
you have 1.6 meters. So you've got to be careful, right? You're dealing with two different units. So it's better if you can change it to the same unit first.
Yeah.
Now what is 85 centimeter? How many meters are we talking about? 85 centimeters is the same as 0.85, right?
Yeah.
So in other words, is 1.6 minus 0.85. So the difference is, 0.75 meters, or you can say 75 centimeter.
Yeah.
Yeah. Oh, but it says here now both. Sorry.
Both measurements are in meter.
No. I'm just trying to get back to the question. Yeah, it doesn't matter. Your answer can be centimeter or meter, right? Because it doesn't say which unit you need to use. Okay. Now, Dana's recipe for the soup calls for 150 milliliters of olive oil. Then Dina wants to triple the recipe. Triple means you multiply by
3.
3. Very good. So 150
450.
times 3 is 450, or you can change it to 0.45 liters. Yeah, because it's asking you
liter.
how many
liters,
right? Not how many, milliliters. So how many liters? So convert between US and metric systems. So basically, for example, if you have ml of water and you try to change it to ounce, right? In that case, you need to know what is the relationship between ml and ounce. For example, let me see if they have the information here.
Actually, it shows up the upper side.
Okay, wait. Here, yes. Yeah. So ounce, so volume, yes. So like ounce to ml here, okay, ounce to ml. So as you can see, 1 ml, sorry, 1 ounce, right,
is equal to 30 ml.
Yeah, equivalent to 30 milliliter. So because of that, you simply divide the milliliter by 30 in order to get the fluid ounce. Okay. Be very careful here. When we talk about the volume, okay, the ounce here we call it the fluid ounce. Okay. Versus the OZ here is the weight. Okay. So that's why sometimes people who are not familiar with the US system, they get confused. OZ can be can be used to measure the weight or the volume. So here they make it easier for us. They call the volume 1 fluid ounce. Okay, And then here, the ounce here is for the weight. Okay. How about this one? It's about changing from the kilometers to miles. So again, she passes the sign that she says the next rest stop is in 100 kilometers. So 100 kilometers to miles.
62.175.
Here, right? Yeah, 1.61. 1 mile equals to 1.61 kilometers. So basically, you are talking about
100 kilometers.
100 kilometers. So you change it to miles, right?
62.137 miles.
Yeah, exactly. You divide it by 1.61.
0.6 miles.
You know, and yeah, this is to change from Fahrenheit to Celsius. This is the formula, right? It's actually not as bad as you think, okay? All you need to do is to plug the number here, and because the formula has already been given to you,
Yeah.
okay? So if you know what the Fahrenheit is, you can easily calculate the Celsius. If you know what the Celsius is, it's easy for you to do the Fahrenheit. For example, this one, they give you the Fahrenheit, right? So all you need to do is to put the 50 to the first equation. So 50 minus 32 is 18, right? 5 over 9 times 18 is 10. So the answer should be sorry, 10 Celsius,
10.
right? Yeah. So, and yeah, and I think this one is pretty much the same, but this time they give you the Celsius, and then all you need to do is to put the Celsius to the second equation, and you should be able to calculate the answer. And the answer is
68.
68. Yeah. So, you know what? We're finished. Okay. So, now I want you to be clear, because right now this class is the Unit 6 class. Okay.
Yeah.
Unit 5 is your midterm test, and there's no assignment for Unit 5. Because of that, you don't need to submit anything tomorrow.
Yeah.
Okay. However, next, not this Sunday, right? But the one after, which is the 14th of August, you need to submit.
Assignment 3.
Yeah, sorry, I need to go to the. No, this is microeconomics. I need to go to. I'm teaching
Next.
3 classes today. Okay, Priyan still know what I mean by that. Okay, so you go to Unit 6, and there should
assignment
be
4.
the unit assignment 4. But remember, this one is due not tomorrow, but by 11 p.m., which is, well, this is the Eastern time, right?
Yeah.
Yeah, the
Yes.
11 p.m. on the 14th of August. So that's
Sir,
it.
if we possible, we do this assignment this Sunday and we can submit it this Sunday.
Of course, you can submit it anytime before that. So it's totally up to you. And I think, yeah, that's basically it. It's very straightforward today. And I'm so